My name is Luke Howard. I'm with the Washington State University Energy Program. I'm a building science specialist. I've been in the industry of energy conservation, indoor air quality, and sustainable buildings for over 10 years. Part of the difficulty in selling thermal envelope and air barrier measures to increase efficiency and durability of a structure is the client can't see the work you have done because it's behind walls or in the ceiling or in the floor. With the thermal imager, you could take a before and after picture and visually show them the work that you have done. It helps you quantify what you have done and the savings they may expect to see.
Hi, I'm Tom Linhard. I work at Avista Utilities. I'm the person in charge of gathering information for energy efficiency for our customers. We go to customer sites to help them understand how the energy flows through their site. I have always loved energy efficiency. I've always loved distributed generation, all the things that go with it. As long as I can get the same service with less energy, I should be trying to do that. A customer may not understand how they're using their energy, and they're only getting a big picture view of where all the energy is entering their building. If I do everything right, if we get the accuracy and the dependability we need out and our shareholders and stakeholders and customers are all happy, then I can go home and play with the instruments that I enjoy.
The tools that we use are very important for me to understand how buildings work. When we travel the country teaching industry professionals the principles of building science, we use quite a few tools for measurement, including infrared thermography, which is a very important tool in order to identify building envelope deficiencies, air barrier deficiencies, moisture-related problems in the building envelope, as well as even possibly pest problems.
Accuracy is highly important for what we're doing. Going and using a cheap meter, is kind of junk in, junk out is what we think about it. And so, having something that's accurate, reliable, storage capabilities, those are all very important to what we do, because we're not looking at stuff typically in just a one snapshot point in time. We have to, you take a mechanical system, you've got to look at it over a period of time. Could be different seasons, could be different operating conditions, unoccupied versus occupied. And so we need to know how it's operating over that life cycle so that we can apply the correct savings calculations to the project.
We need accuracy, we need repeatability, we need dependability, we need ease of use, and we need safety. And so that's what we look for in the instruments we choose.
When we're taking measurements in these big industrial facilities, we're connecting to very large equipment. And so it's very important that we're not only getting accurate measurement, but that we're also being safe at the same time. So having safe and reliable equipment is very important to us when we're in the field.
A lot of that energy renovation work we do is called, it's performance contracting. So we're actually at risk for some of the fee if we don't meet the savings guarantees that we've given them. And so obviously it's in our best interest to make sure we have good information on the front end so that when we validate it a year or 2 or 3 years later, that we know that we started with some good information and that we can end with some good information.
It all comes down to the bottom line, saving money. Saving energy helps the environment, but when you're trying to sell it to your boss or sell it to management, if you go in with an informed decision using a measurement, you get a lot further than just saying, oh, it's just going to save money or save energy.